So this is my presentation. It's basically an AI basketball shooting form coach powered by YOLO. And first, the problem identification. Like I said previously, like the shooting forms, if a coach sees the shooting forms, he'll be able to recognize, oh, your elbow's too outside, or like, oh, you're not stepping into your shot. But if you're like an amateur or a beginner, or like if you're asking a friend who's also amateur, like, hey, does this shooting form look good? Your responses will probably look like, oh, it looks fine. I don't see any problem. When there is, and this can be a problem because shooting is like a very key part of basketball. And if they can't identify that they have a problem, then they can't solve it. And that could like very limit their like growth in basketball skill. Um, so basically what this project does is first, it has five like steps or objectives. First, you like upload a video or a picture of you shooting, and it basically detects your pose. So it finds 17 key points on your body, and then step two, those key points like they draw lines between them and calculate the angles to see like to analyze your shot. And then step three, that those angles are then compared with professionals as well as our data set, image data set that we used to get a 0 to 100 score based off of like professionals and their like standard shooting forms. And step four, it gives you um, a pro player that your shooting form is most similar to. And this might seem a bit off topic, but I thought this was like useful because maybe you would like watch that player shoot and learn from them, and it'll be like a role, you can give them like a role model. And finally, step five, it gives all the data that it collected to the LLM, where it gives you like a personalized coach. It gives you suggestions and what kind of practices you should do. So if you see it in action, there's three tabs, and which all gives an score through A through F, and gives red flags, pro player matches, and Gemini AI coaching text. Can I show an example of the app, or should I wait for that after?
Yeah, we'll just jump to it later.
Okay. So first, the image upload part. You can upload any type of image, and it identifies uh what phase of shooting it is, and then compares those angles of the shooting form to the optimal shooting rate angles of that phase. And video upload, it takes a video and analyzes every frames, or you can make it analyze every few frames, and it basically calculates it for every frame and gives like an average score, and it also gives you like the top score and what you need to work on. And finally, the live webcam, it basically turns on your webcam and it's like a live scoring. So if you go like this, you can see the scoring change like every frame. So basically the process on how this model works. First, the user uploads a video or a picture or turns on the webcam. And then two, as I said before, YOLO, which annotates like the key points, detects the pose and annotates the image, and then the model like draws lines through each key point and draws the angles, and then that gets put into an XGBoost and KNN. The XGBoost generates the score by looking at all the other data, and KNN uses the data of NBA players or the professional players and compares it to see which one you're the most similar with and gives a percentage of how similar it is. And finally, all those data get sent to the LLM, or in this case, Gemini, to give you coaching. Like, oh, this is a red flag. You need to fix this. Oh, you should do this drill to fix this. And you're doing good here. And each stage is very modular and independently testable. So there's four sections or layers in this model. First, there's the front end layer, which there's only one script, app.py, and this basically uses the Streamlit library to generate a front end, which is basically what the users are going to be looking at and interacting with. Then another one, the inference layer. This layer, there's image inference, video inference, and frame inference, and these will basically draw the annotations and draw the angles of each frame or image. And this gets sent to the analysis layer, which will analyze and compare that data to the data we already have and give you a score. And finally, the AI layer, there's one script, the main.py, which basically sends all that data to Gemini and outputs it for the users to see. And the scoring, how it's scored, there's all of the angles are weighed differently because, for example, elbow angle is the most important because it determines the trajectory. And all of these are important, but these are it's weighted by the most important to the least important. And the scores are then, if it's over 88%, it's an A, and if it's over 75%, it's a B. If it's over 60%, it's a C. It's over 45%, it's a D, and anything under 45% is an F. And also, as I was talking about, the 6 red flags. First, the chicken wing, which is basically when your elbow is very wide, flat release, like you release very flat. No leg drive, basically like you're not using your legs. Sidearm wrist, your wrist is not aligned, so it shoots that way. Hip drift is basically when your hip shifts when you shoot, like making your upper body move. And low arc is basically when you release too low, resulting in a lower trajectory. And the technology or the library used in this model, first, we have the YOLO, which annotates 17 key points of your body, which then OpenCV uses to, first OpenCV like gets the image or frame ready, which then the YOLO annotates it. And then after that, OpenCV comes back and then like calculates the angles and draw lines between them. And then that gets sent to XGBoost, which generates scores based off of like other data that it has. And KNN compares that data to players' stats or like players' data to compare it and see which one it's most similar to. And then where we use Gemini to generate the personalized coaching. And finally, for the front end, we use Streamlit because it was the most easy to use. And I was talking about the Streamlit is our front end. It, as I said, it has 3 tabs: image, video, and webcam. And you can drag the files into the website for easy use. And as I said, it generates and shows you your annotated skeleton, so you can like visualize it better. And for the video, it also gives you a downloadable link, which you can download your fully annotated video. And after that, it gives you the session summary dashboard, which is basically like the score, your red flags, your comparison to other players. And then below that, it gives you the Gemini AI coaching text box, which is basically the personalized coaching. And finally, off to the side, there's the API key configuration. We had to do this because we couldn't use my personal API for everybody to use. So the users will have to get their own API key if they want to use the LLM. And as I explained in the backend Python, it draws angles, basically what I said. And finally, who this is built for, what could be the uses. First, as I said, the amateur players, the players that want to get better but don't know how or don't have like access to coaching. This is important because without this, like they don't know what they're doing wrong, therefore they can't get better. And first, secondly, youth academies. Like my team, we do have a coach, but this coach has to watch like 20, 30 people. So not all of us can get the attention we need. So by using this website, we are able to like know what we need to improve on. So we can like think about that while we practice and ask the coach about questions with that data in mind. And sports researchers, this is, instead of like having very high-tech gear to measure all of your angles so then you can learn about the trajectory, we can use this AI model that I created to just measure all those angles without those high tech gear, leading to like easier research. And finally, as I said, coaching trainers. It's kind of related to the youth academies, but I think coaches will be able to train the players more effectively and efficiently if they had prior data before telling them what they need to do, because that'll eliminate the time to like look at the player's shooting form and analyze themselves to analyze what's wrong. And basically, with like instead of like going through all the hassle, any player who has a phone can use this website to get all the data they need to get better. That's it. Thank you.
Okay, you can stop the presentation.
Should I go on to demonstrate?
Yeah, we will just let it. I just have some compliments regarding your presentations.
Okay.
Okay, so the way you were presenting, I have taken more than I just don't remember more than it's like 40 to 50 interviews in past few days. The way you were explaining, the way you were passionate about the basketball, the way you were passionate about your project, it was like mind blowing. The way you were explaining each and every terms that the joints were like attached to the elbows and everything, the way your project works, the way the AI detects the motion, the way AI, your project basically detects the gesture and everything. It was mind blowing and it was awesome. And the way you have presented, I think so it was around 10 to 12 slide presentation, right? It
It
was,
was
it seems like it was very much easy to explain someone, but the way you explained, it was just amazing.
thank you.
Right. And I just want to know how did you just created that motivation? Like how did that like confidence you got while you were explaining this thing?
Well, I was having a lot of fun while creating this model, and also I had a really good mentor who taught me a lot and dag like right really deep through each like concept, which like led me to have a deep understanding and also gave me the confidence like of me thinking, okay, I fully understand this project. I know what's going on.
Because just like the way you were explaining, it seems like if I'm going to ask you any question, you have each and every answer to my every question. The way you were explaining. Okay, so I'm just curious to know how the project works.
Oh, how the project works. As I
Like,
said,
can we just jump to the demonstration part?
okay.
Yeah.
So this is basically the interface. We're using a Streamlit cloud, and basically I just imported my GitHub into this so this can work. So first we can try out, see, as you can see, there's 3 tabs and the Gemini API key that I already put in. So first, let's try an image. I already have an image of Steph Curry ready to use. And when I use it,
It seems like he's your favorite basketball player.
yeah, I have a uniform. Then I can check this Gemini AI coaching after analysis and analyze the image. First, it gives us an annotated image so we know what's going on, and it also gives you a score, and like you can visualize the data more. And that, below that, we get a score and what the model thinks is the phase, which is correct. This is the follow through. And it gives you the score based off of the angle and the ideal angle.
Okay.
And below that, it gives you a few formula alerts or the red flags that I mentioned previously. And it also gives you a priority of what you should work on. And below that, this is the XG boost score, which is basically using, so this is using the angle, like standard angle, but this is using all of our data sets and comparing it to generate another score, which could be more accurate. And after that, this is the pro player matches. Apparently, it's the most similar to Kevin Durant, but I think this place still needs more work because it's sometimes not accurate. But as you can see, Stephen Curry is the second highest here because it is Steph Curry. And then
Got it.
finally, the Gemini coaching feedback. This one, since this form is like really good, it doesn't give that much like things to work on, and it first gives you an
Good.
overall assessment. It's like, oh, your form is very great, but it gives you what you could work on and a specific drill. And then so for the and then it gives you improvements you can work on that are not the highest priority, but you can still work on it and think about it. And it also gives you a final conclusion at the end.
Okay. Got it. And I'm just impressed with that one thing. You have uploaded an image. Can you just scroll down to the image? I can see there are many more persons in the image, but it still detects the basketball player. It's very much impressive.
Right.
Like it says that you have created tools that is much accurate regarding the posture and everything. So
Hmm.
I just have a quick task for you. Can you just like get a download one of the image from Google, and can you just upload that now online? And we will just check the tool is working properly or not.
Which one would you like to use? I'm gonna do a professional.
Oh,
It's better if the whole body is there. So maybe
I think so. That one works properly.
maybe this one.
Yeah, yeah.
I will.
So, like, do you have any prior knowledge regarding this coding and AI/ML knowledge?
I don't have any AI knowledge, but as I said, I have prior programming knowledge with the game development. And also before this program, I took a really simple, really like basic Python learning course to prepare for this course.
Which one, if may I know?
No, so I took a Coursera course,
Okay,
like the crash course for
like
Python.
it's okay. It's like some a pre-recorded session you had before
Yeah.
in that course. Yeah. Okay, okay. Like, can we? It's like uploading.
Yeah, I uploaded it. I dragged it.
Okay.
As you can see, I can, and then now it
Oh,
shows you the guy's shooting form, gives you the score, and then as it's also follow through. This
okay.
guy maybe hip knee alignment could be better. As you can see, he's kind of like fading,
Yeah.
so I think that's the problem. Um, Priority, and then the red flags, the XG boost, the pro matches. I think this player is not in this data set. That's why he's not showing up, and
Okay.
also the Gemini coaching.
Okay. Got it. So I'm very much impressed by the way your tool works. As you can see, can you just like scroll down to the image? We have too much noise around that. There are other basketball players. Still, there are thousands of people behind the image. It doesn't detect them all. Can you just like explain me why and how you just made that?
I think what I did was the Open CV. There was like this thing that made it so that like only one thing gets detected, and it also like I used the prior data sets to like kind of make the model understand who's shooting.
Okay, got it. But like, can you explain me how in the technical terms?
So basically, like I have this, like I have a 4,000, I have 4,000 pictures of people shooting, and basically when I put that in the model, it kind of like learned which one is like the shooting guy and which one's distractions. And also you can like restrict how many people's gets like the annotation, because before when we first tested it, like every single person in the background got the frame annotation and it really messed up the result. So we had to come up with a solution to like make sure only one person gets the annotation.
Got it. Sounds good, sir. You have worked very well on that. And did your mentor help you for those thousands of picture collecting those thousands of how did your mentor help on that?
So my mentor actually recommended a video data set because it would be like more accurate, but I think we spent classes or two like sessions looking for good data sets, and we ended up with pictures, and he thought that was a problem, but he told us like, oh, if we're gonna use this, we have to work extra hard and we have to like make sure the model knows which kind of phase he's on. And basically, we just kept searching and searching and searching, and we finally found this data set on this website called RoboFlow. where it had about 4,000 images. So we uploaded that and used that for the data set.
This sounds good. So you have worked so hard on this project. So I like it was a frustrating part that you have to search that data set, or it was like interesting.
It was a little bit frustrating because we tried to get like numerical data, like the shooting angles of every player, but that didn't work out that good. So then we were like, oh, we can compare the input with the data, and we wanted a video data because that would like put every single frame. But all the video data were like either very spread out and was covering the entire game, or it was like very glitchy and very like low quality. So we ended up using high quality picture data.
Okay, and I think so. Rather than having a numerical data, it's good to use a photos data, but it takes some time to upload and do everything because it's a huge data. But still, it gives a accurate like result as it can detect the image of the image and the coordinates and everything.
Right.
Yeah. Okay. So like, I just want to yeah, you can just stop sharing the screen.
Oh, do you not want to see the video and webcam maybe?
Oh,
No.
you have the features. Oh
Yeah, I
yeah,
made pictures. And then for the video, I have a video of my little brother shooting, if that's okay. So this is basically my little brother shooting.
oh nice.
And then this can like choose like how many intervals you want between the frames. But since this video is really short, I'll just put it to one. This can also change how many max frames you want to analyze, but if I remember correctly, this video only has like 40 or 50 frames, so this is okay. Then check it for the coaching.
I was just amazed that you have also integrated this like functions into the AI tool that is just a basic. Sounds good.
So this basically first it gives you a downloadable video that if I open it, um, give me a sec. I need to move this here. It basically gives you an annotated video of the entire thing,
Oh,
and
nice.
it's like lively updated up here the data. And
It's saying like I'm seeing from a eye of a robot.
and basically after that it gives you like pictures of some of the examples if you don't want to download it. And then the average is scored is basically it gives you the percentage of frames that it was good. So this means that 6.2% of the frames had a had a good form. And this one, oh, he did amazing. All of the frames had good hip alignment, but only 9.4% of it had wrist elbow vertical like matching. And
Okay.
basically it gives you, oh yeah, these elbow problems in these amounts of frames, these amount of frames. Then it gives you your best frame. Apparently my little brother's best phase is a follow through, which had this score. And then it gives you red flags, gives you the XG boost, which is more accurate, and then
Okay.
gives you the most player closest player, but he's not that close because it's only 18.3% match. And then Gemini feedback, since he had a bunch of problems, this is kind of long. This is in the longer side. He's telling us, oh, you need to improve. You're really bad at this. We can use this drill to get better. And then two other problems you have is, oh, your knee angle's bad, your shoulder angle's bad. And then it gives you encouragement at the end so you don't feel down.
Got it.
And this is all generated by the LLM after it gets data.
Okay. Got it. So it just tracks the data from the images, right?
Right.
Okay. Got it. Can you just demonstrate me? I'm just like excited to see the webcam part.
Okay, the webcam part. So we first ran it with on like the local and it worked. But then when we tried to upload it on Streamlit Cloud, was too heavy and it required the GPU, which the cloud doesn't offer. So we moved from this other library to this library called Streamlit WebC or something, which basically lets you use the Streamlit browser and then it makes the like analyzing like more available on Streamlit. So if you just let it load for a second. So um
Nice.
so it gives you like a thing, and if I like kind of go like this,
Woo. Okay.
it gives you a live score. So maybe this
Do
is
do you have a basketball around you?
oh I think I do. Wait, give me a second.
Yeah.
So I have a basketball,
Okay.
and then I shoot it. You can see that the score keeps changing live. And I can't really shoot that much because I'm in a room, but if I like bend my knees more, the knee score will go higher. And if I go like this, the elbow is terrible because it's basically straight, but when I bend it, it goes higher. I think it goes higher. And yeah, basically it's live scoring. So you can check your form anytime.